Unfolding, enveloping missiles of soul. Recall senses sadly. Mirage like, softly like lanterns below. To light the way.
Okay, section 2.4 is on mixed operations. It should say operations, shouldn't it? It's kind of weird, mixed operation. Anyway, basically I'm not teaching you anything new today because all you're doing is adding, subtracting, multiplying, dividing rational expressions, but you're doing it all mixed up, right? You got some adding, some multiplying in this question. You got some subtracting, some dividing in this question. So we need to remind you about BEDMAS. And I know you know this, so I'm going to blaze through this very quickly. B stands for brackets, E is for exponents, D is for division, M is for multiplication, A is for addition, and S is for subtraction. And if you don't remember what I'm talking about here, these are the order of operations. In other words, this is the correct order to do math in. The first thing you do is you look for brackets and you do those. The second thing is exponents, etc., etc. Also, remember that I teach it like this, which means that division and multiplication are equal to each other, and addition and subtraction are equal to each other. So in other words, you do, if you have a division and multiplication in the same question, you do whichever one comes first from left to right. If you have addition and subtraction in a question, you do whichever one comes first. So if you had 5 minus 3 plus 8, even though addition comes before subtraction in BEDMAS, you wouldn't do the addition first because addition and subtraction are equal to each other. You do whatever comes first, and subtraction comes first. So you do 5 minus 3 is 2 plus 8 equals 10. Alright, so let's get started. There's only 3 questions, but they're really big questions. So in the first question, we have one rational expression, we're adding another rational expression, and we're multiplying another rational expression. What do we got to do first? We got to multiply. So we're going to do this first. So how do we multiply rational expressions? Well, the first thing we do is we factor numerators and denominators. So the first one up here is a simple trinomial. So we have x and x. We're looking for two numbers that multiply to 3 and subtract to 2. That's 3 and 1. So the big number here, 1 there, drag down the negative, and negative times a positive equals that negative. Okay, on the bottom, another simple trinomial. So again, it's x, x, two numbers that multiply to 6 and two numbers that multiply to 6 and subtract to 1. That is 3 and 2. So big number here, small number there, drag down the negative, and negative times a positive equals that negative. Great, we're going to multiply all that by, here we have a greatest common factor we can take out. The greatest common factor is x, and we're left with x plus 2. And here we also have a greatest common factor of x, and we're left with x minus 4. Great. Now, why don't we get the non-permissible values? So we look at the denominators. What would make the denominators equal 0? Well, if this bracket was 0, then the whole denominator would be equal to 0. So what would make this factor here, this bracket, equal 0? 3. X cannot equal 3. What would make this bracket equal 0? Negative 2. What would make this x equal 0? If x was 0, so you can't have that. And what would make this bracket equal 0? If x was 4. So those are MPVs. There might be more when we deal with this, but for now, those are all the MPVs. Okay, now we get to cross stuff out. Well, there's something on top and something on the bottom. There's something on top and something on the bottom. There's something on top and something on the bottom. Wow, we don't have too much left. All we have left is x plus 1 over x minus 4. Awesome. Now what we have to do is we have to add. I'm going to keep it in the same order. This doesn't really matter with addition. You could put plus the other one over here, but with subtraction it makes a big difference. So I'm going to keep it in the same order. We have the x minus 2 over x plus 5, and we're adding it to all this. So what do we do to add rational expressions? Well, the first thing we have to do is we have to factor the denominators, and they're already factored. There's nothing you can do. Next thing you want to do is look for MPVs. So what would make this one equal 0? If it was negative 5, and we don't have that one yet, so we'll add that. Whoops. We'll add negative 5. And what would make this one equal 0? If it was 4, but we already have that one, so we're good. What's the lowest common denominator of this? Well, the lowest common denominator is x plus 5 times x minus 4. So we want both the denominators to be like that. We want it to be x plus 5, x minus 4, plus another x plus 5, x minus 4. So what do we have to multiply this first one by? Well, obviously we have to multiply the x plus 5 times x minus 4. And you got to do the same to the top. What you do to the bottom, you do to the top. So let's do that. This is a mountains and valleys here. So we have x times x, which is x squared. I'm going to try to do this in one step again. X times negative 2 is negative 2x. And negative 4 times x is another negative 4x. So we had negative 2x and a negative 4x, which gives us negative 6x. If you need to write that all down, go for it, but I want to save some time. And then we have negative 4 times negative 2, which is plus 8. Okay, we look at this one. What did we need to multiply x minus 4 by to get x plus 5, x minus 4? Boy, that's awful. That's x plus 5, x minus 4. It's just terrible. So we had to multiply it by x plus 5, and we have to multiply the top by x plus 5. So again, we have mountains and valleys here. X times x is x squared. X times 5 is 5x, and 1 times x is 1x. So 5x and 1x is 6x. And 1 times 5 is 5. Great. Now we're going to combine those. So when you add rational expressions or add fractions, what happens to the denominator? It stays the same. X plus 5, x minus 4. And we combine terms up here. So we have 1x squared and another 1x squared. So that's 2x squared. We have a negative 6x and a plus 6x. What's that give you? 0x, or 0, so nothing. So that's done. And we have an 8 plus 5, which is 13. Look to see if you can factor the top, and you can't. So we're done. The last thing we'll do, although your book won't ask you to do it, is to put the NPVs. So x cannot equal, should we put them in order? Negative 5, negative 2, 0, 3, and 4. You don't need to put them in order. And that's one question done and 2 to go. Alright, next one. We have a subtraction step, we have a division step. What must we do first? Division. So with division, again, you are factoring before you do anything else. So we're doing this first. Factor that. That's a difference of squares. What multiplies by itself to give you the x squared? X and x. What multiplies by itself to give 4? 2 and 2. One sign is plus, one sign is minus, in any order you want. This one, just factor out an x. And x plus 2. Okay, now I know most of you are going to flip, so even though I didn't do this last video, I'll do this just because I need to remind you that you're making it a little bit more difficult for yourself. So this is going to flip to the top, right? Where we're doing the reciprocal of this. So on the top, we have the 2x squared plus x, and we're going to factor that. What can we factor? We can factor out an x. X times 2x equals 2x squared, and x times 1 equals x. Good, now we have to factor this. This has come to the bottom, right? That 2x squared plus 7x plus 3 has come to the bottom. We have to factor that there. Uh-oh. Can you see what kind of factoring it is? You bet. It's Bobby Bridge. We're looking for two numbers that multiply to 6 and add to 7. It's 6 and 1. Let's just do this over here, and then I'll put the final answer over here. So we write down the 2x squared. I said the numbers were 6 and 1. So to get 7x, you have to add them both, 6x and 1x. And then we rewrite the plus 3. Now we're ready to pair them up. So in the first pair, the greatest common factor is 2x, and we're left with x plus 3. In the second pair, the greatest common factor is just 1, so we're left with x plus 3. Hey, look, we got the same thing in both. Let's go straight down to here. So in one factor is going to be x plus 3, and the other factor is going to be 2x plus 1. Okay, here's where you could get into trouble when you do the NPVs now. So if we look at this denominator, what could x not be here? X could not be 0. If we look at this denominator, what could x not be? It couldn't be negative 2. If we look at this denominator here, it couldn't be negative 3. If we look at this denominator, it's a little tricky. You might need to write this down. 2x plus 1 cannot equal 0 and solve it. So you'd move the plus 1 over and become negative 1. Negative 1. And then we divide by 2, so you'd get x cannot equal negative 1/2. Hopefully you followed that. That was pretty messy. And a lot of people will stop there. They'll say, that's it, I found them all. You did not find them all. This was at one time, this right here was a denominator. So even though it's not a denominator here, once you factored it, you have to consider that one as well. So don't forget, what would make this equal to 0? If x was 0, we already have that one. What would make this one equal 0? Well, that's exactly the same as this one. So you would have gotten lucky. You would have gotten it right because there's no new ones up here. But be careful. Just to be clear, this 2x plus 1 is exactly the same as this. So you get negative 1/2. That won't always be the case. So you need to consider top and bottom here. All right, so we've done the MPVs. Here we're ready to cross stuff out. There's an x and an x on the top and the bottom, an x plus 2 and an x plus 2 on top and bottom, a 2x plus 1 and 2x plus 1 on top and bottom. A nice rational expression is left, x minus 2 over x plus 3. And again, I'll show you what would be incorrect. A lot of people do this. They say, great, I got that answer, and now what I want to do is subtract x plus 1 over x plus 6. That's wrong. You can't do that. Order matters when you subtract. So what you want to do, oh, this would be awesome if it worked. Ah, not bad. You want to put that out front and put your subtract sign here. That's what you need to do. Okay, to subtract rational expressions, we factor the denominators. It's already done. We look for MPVs. So one MPV here for this one would be negative 6. Oh, we don't have that one yet. And the other one would be negative 3, and we do have that one. So that's good. Now we get our lowest common denominator, which would be x plus 6, x plus 3. So what we're going to end up with is the first one with a denominator of x plus 6, x plus 3. Take away the second one with a denominator of x plus 6, x plus 3. So what do we have to multiply the first one by? Obviously by x plus 3. Be careful, people have such troubles with this chapter, and it's mostly because they try to skip steps. I know this takes a long time, but if you skip steps, your chances of getting it wrong are just go through the roof. Okay, so we're going to do mountains and valleys. X times x is x squared. X times 1 is 1x, and 3 times x is 3x. 1x plus another 3x is 4x. Okay, 3 times 1 is 3, as the fire engine goes by here. Good, we're ready for the next one. What do you have to multiply x plus 3 by to get this? You have to multiply it by x plus 6. Where am I going to write this? And same with the top, you need to multiply by x plus 6. Mountains and valleys, x times x is x squared. X times 6 is 6x, and negative 2 times x is negative 2x. So 6x, take away 2x, is 4x. 4x. And finally, negative 2 times positive 6 is negative 12. Okay, we're going to combine those. So obviously we're going to have the same denominator, x plus 6 times x plus 3. Now be careful, remember this subtraction sign refers to everything. So you could make it a plus and change all the signs, negative x squared, negative 4x, and plus 12. But again, I'll do it the way a lot of you do it, and I'll just show you the way you should think this through. You should think to yourself, x squared, take away x squared is 0. You don't have to write anything. 4x, take away 4x is also 0. You don't have to write anything again. And positive 3, take away negative 12. That's the same as positive 3 plus 12, so it just equals 15. Obviously you can't factor that, so you're done. Write down your MPVs. X cannot equal, let's put them in order, negative 6, negative 3, negative 2, negative 1/2, and 0. And we have finished the second question. One to go, and boy doesn't that look scary. That just looks like a mess, like we've made a mistake or something. Actually what this is a complex fraction. And what a complex fraction is a fraction that includes fractions. So there is one kind of giant fraction here. The giant fraction has its line, I suppose, its bar. I don't know if there's a name for the bar in a fraction. Someone look that up. It has its bar right there, and everything above that, all this up here is the numerator of that fraction, and everything below that, I'll put it in pink, that's the denominator of the fraction. But within the numerator there's more fractions, and within the denominator there's more fractions. Now there's a couple ways you could solve this. One way you could solve this is you could find the common denominator of all four of these, the x plus 4, the x minus 4, the x plus 4, and the x squared minus 16, and multiply everything by the lowest common denominator. That's fine. The other way you could do it is you could consider just the top and get an answer, just the bottom and get an answer, and then divide. And I kind of prefer that method. So let's do that. So first of all, we're going to work on the top here, just the yellow part here. Okay, so I've got 1 over x plus 4 plus 1 over x minus 4. When I add rational expressions, I need to factor the denominator. You can't do anything left. anything else here. Got to find the MPVs. So what would make this one equal 0? Negative 4. So x can't equal negative 4. What would make this one equal 0? If x is positive 4. So just let's make it plus and minus 4. Need to get a lowest common denominator. In this case, the lowest common denominator is x plus 4 times x minus 4. Okay, so what we're going to end up with is two fractions that have denominators of x plus 4, x minus 4, and we're adding another fraction with x plus 4, x minus 4. What did you have to multiply x plus 4 by? Well, obviously by x minus 4. Do the same at the top. You're left with 1 times x minus 4. That gives you x minus 4. What do you need to multiply x minus 4 by? Had to multiply by x plus 4. Do the same at the top. What's 1 times x plus 4? X plus 4. Great. I'll put it here. So the denominator is going to stay the same. X plus 4, x minus 4. And on the top, we have x plus x, which is 2x. And we have negative 4 plus 4, which gives nothing. So this is it. There's our answer. Try to factor the top, but you can't, so you're finished. All right, now we'll work on the bottom. I'll do that in purple. So we're adding again. First step is to factor the denominators. You can factor this denominator. So we have x over x squared minus 16. That's a difference of squares. So x times x equals the x squared, and 4 times 4 equals the 16. Make one plus, make one minus. Plus 1 over, you can't factor that, it's done, so 1 plus x plus 4. Okay, we need to get our MPVs. Where am I going to write this? I guess here, MPVs. X cannot equal, well, it can't be negative 4 here, which we already have. I guess I could just add to this. It can't be negative 4, we already have. It can't be positive 4, we already have that one as well. And it can't be negative 4 again. So we already have that. Let's not even bother. We've already got them written. We do need to write down a lowest common denominator, though. The lowest common denominator would be x plus 4, x minus 4. So what we're trying to do is to get two fractions that have denominators of x plus 4, x minus 4. We're adding, we're going to get another fraction with x plus 4, x minus 4. Great, well the first one already has a denominator of x plus 4, x minus 4. So you're not going to do anything, or if you want, you're going to multiply it by 1. Multiply the top here by 1, you still have x. This one, however, you need to multiply by x minus 4. Do the same to the top. 1 times x minus 4 is just x minus 4. Great, now we're ready to get our final answer here. It's just going to have the same denominator, x plus 4, x minus 4. X plus x is 2x, and then nothing, I suppose, plus negative 4 is negative 4. Can you factor the top? You can. You can factor out a 2, so you should do it. 2, what you're left with is x minus 2, all over x plus 4, x minus 4. Awesome, that was a lot of work. But we're not done. Now we need to do this division, right? This red line here, that division right there, we have to do it. So we have to take whatever this equaled, which was, which I do this in green, whatever this equaled, the top part, which was this right here, 2x over x plus 4, x minus 4, and we need to divide it, because that's what that red line means, divide, by whatever this equaled, and that equaled 2 x minus 2 over x plus 4, x minus 4. Okay, let's do our flipping here. So what you'd be left with in the first one, it just stays exactly the same. 2x, x plus 4, x minus 4, times, second one's flipping, so x plus 4, x minus 4 goes on top, and 2, x minus 2 goes on the bottom. Let's think about our MPVs for a second here. What are MPVs? Well, remember, we have to look at all the denominators. So this is negative 4, got that one already. This is positive 4, this is negative 4, this is positive 4, negative 4, but look at here. This is 2. What would make that one equal 0? Well, nothing would ever make that equal 0. It's 2. But what would make this one equal 0? Positive 2. So you need to add one more NPV of 2. So I'll go back up here and I'll put 2. Right? Whenever you divide, you have to be careful because you get that extra denominator popping up. Great, we get to cancel out. Look at the things we get to cancel out. X plus 4, x plus 4, x minus 4, x minus 4. 2 and 2. You can do that in a monomial, so that's fine. Boy, we're not left with much stuff. All we're left with is x over x minus 2. And then we'd write all the MPVs. X cannot equal, what was it, plus and minus 4 and 2. So plus or minus 4 and 2, and we have finished. Nothing new, but that doesn't make it easy. My hint, as I said before, is to not skip steps, or skip as few as possible. I know I skipped a few in there, but I did a lot of steps. I could have done them much faster, but you know what? I get them all right because I don't skip a lot of steps.
Where the whiteness will